the bridges that should never have failed. Behind these engineering marvels are stories of ambition, mistakes, and lessons written in tragedy. Welcome to Cadrer Daksh, where we explore civil engineering stories, innovations, and failures that changed the world. A bridge collapse is rarely sudden. Hidden weaknesses often grow silently for years before disaster strikes. Every failure revealed one truth: even the smallest weakness can challenge the strongest structure. Our story begins with Tacoma Narrows Bridge, a masterpiece that became one of engineering's greatest warnings. Completed in 1940, its elegant design made it famous. But soon, the bridge revealed a dangerous secret. Soon, the bridge began moving strangely. The roadway appeared to rise and fall like waves across the water. The famous Galloping Gertie movement was not harmless. It was a warning engineers could not ignore. On November 7, 1940, the bridge collapsed. Violent twisting motions were caused by wind. The disaster changed bridge engineering forever and taught the world the importance of understanding wind forces. In 1967, another bridge connected communities across the Ohio River. No one knew its final journey was approaching. The Silver Bridge was considered a modern achievement, carrying thousands of people every day. On a busy December evening, cars filled the bridge as families traveled home, unaware of the danger ahead. Without warning, a small structural failure began. Within moments, the entire bridge was in danger. The collapse claimed 46 lives and became one of America's deadliest bridge disasters. Investigators discovered that a tiny crack in one steel component triggered the catastrophic failure. Years of stress and corrosion weakened the metal until it finally reached its breaking point. Disaster transformed bridge safety standards and changed how engineers inspected aging structures. The lesson was clear: a single overlooked weakness can threaten an entire structure. But another disaster would prove that even before a bridge opens, engineering mistakes can have devastating consequences. In Canada, engineers attempted something extraordinary: the world's longest cantilever bridge over the St. Lawrence River. The project represented ambition, innovation, and the dream of pushing engineering beyond previous limits. As construction continued, workers noticed warning signs. Parts of the massive structure were beginning to deform. In 1907, before completion, the Quebec Bridge suddenly collapsed in less than a minute. The collapse killed 75 workers and became one of history's worst construction disasters. Investigators found that design calculations had underestimated the forces acting on the bridge. The disaster changed engineering practices, proving the importance of careful design reviews. Completed years later, the Quebec Bridge became a symbol of resilience and lessons learned through sacrifice. Decades later, technology advanced. Engineers believed disasters like these belonged to the past. But in Italy, a modern bridge would soon remind the world that age and maintenance matter. Opened in 1967, Italy's Morandi Bridge was once celebrated as a symbol of modern engineering. Its innovative design was impressive, but some critical components were difficult to inspect. Over decades, traffic, weather, and aging materials placed increasing demands on the structure. On August 14, 2018, a section of the Morandi Bridge collapsed during a violent storm. The collapse killed 43 people and shocked the world, raising questions about aging infrastructure.
Investigators examined the bridge's condition, maintenance history, and structural challenges. This rebar corrosion is significant.
Stress failure is showing here. The disaster accelerated efforts to inspect and protect aging bridges around the world. A question remained: how many hidden weaknesses exist in the bridges we use every day? Different bridges failed in different ways, but each one taught the same powerful lesson.
Every failure created knowledge. Today, those lessons help engineers build safer bridges for the future.
Today, bridges are constantly monitored, helping engineers detect small problems long before they become disasters. Real-time sensors now warn engineers before invisible damage grows into a serious structural threat. Technology helps, but careful human inspection remains one of engineering's greatest safeguards. Different disasters, different causes. One shared lesson: engineering must never stop learning. Every generation builds upon the lessons learned by the one before it. Behind every safe bridge stands the responsibility, knowledge, and dedication of countless engineers. Most people simply cross a bridge. Engineers see thousands of invisible decisions keeping every journey safe. Bridges don't simply connect places, they connect lives. Their greatest strength is the lessons they leave behind.
Thanks for watching Cadre Docs. If you enjoyed this documentary, like, share, comment, and subscribe for more incredible engineering stories.